Greetings, ladies and gentlemen. In this video, we'll be covering exact equations. Okay, this is another method for solving first degree or first order differential equations. Now, to prove that an equation is exact, well, you must write it in this format first, where you have m dt plus n times dy equals 0. And the condition for these two equations to be exact is the partial of the m term, m being some function, or even it could be a constant, with respect to the y term is equal to the partial of n with respect to t. Okay. Now, if this condition is not met, then the method that I will show you in this video cannot be used. Now, one way that I like to remember this is, think of it as MINT, M-Y-N-T. Just to remember, it's just a method to not forget this. Now, let's jump straight into one of the problems here, okay? Let's look at number 1. Number 1 says 2t plus 3 dt plus 2y minus 2 dy is equal to 0. Now, first thing is that this equation doesn't seem to be written in this format. So we have to well, actually it is written in this format. Okay. Now, the next thing that we have to do is see if this condition is met. If the partial of m with respect to y is equal to the partial of n with respect to t. Take the m term right here. So the partial of m with respect to y. Now take the partial derivative of 2t plus 3 with respect to y. Now this equals 0. Now, if you have any question about how to take partial derivatives, then you may ask us in a message and we can create a video just for that. The next piece says the partial of n with respect to t. Okay, that's this term right here. Now, the partial of n with respect to t would end up just being 0 again, because there is no t term there. Therefore, the partial of m with respect to y is equal to this. Now, because this is true, we may proceed on to the method that I'm about to show you next. Now, what you have to do next is you have to say that m is equal to, I'm just going to introduce a new variable right here. M is equal to d psi dt. Now, psi is just another variable, okay, and I'll show you exactly what we use with it, or what we use it for. Now, m is this right here, and this is n. So m is equal to d psi dt, which is equal to 2t plus 3. And n is equal to the partial of psi with respect to y, which ends up being 2y minus 2. Now, all I'm doing is I'm just copying this now. Okay. Now, the next step is we want to solve for psi. Now, essentially, this is what it turns into. So we have partial of psi. If you multiply dt onto this side, becomes the partial of psi is equal to 2t plus 3 dt, or the partial of t right there. Okay. To get rid of this differential piece right here, take the integral of both sides. There we're getting psi is equal to 2t squared divided by 2 plus 3t. Okay. Now I'm just going to stop this for a second and come on to this side. In this case, exact same format, where multiply the dy, or the partial of y, onto this side and get the partial of psi by itself. So we have del psi is equal to 2y minus 2 partial y. Take the integral of both sides to get rid of these differentials, and you would end up getting 2 Well, psi is equal to 2y squared divided by 2 minus 2y. Okay? Now, I intentionally left the constant terms out of this for the time being. Now, this piece right here and this piece right here, when we combine those, we can get our answer. So in other words, our answer for this problem would end up being psi is equal to, now combine this piece with this piece, and keep in mind that if there's any term that repeats between here and here, we would write it only one time. Now this would end up being, simplifying this down, simply t squared plus 3t is equal, or plus, now from this side, y squared minus 2y. Now psi, we can treat it simply as a constant. Okay, we can say it's a constant and say c is equal to t squared plus 3t plus y squared minus 2y, and this would be our general solution. So let's just go back through this problem one more time. The first step is to write the differential equation, if it is not written already like this, in this particular format, where m dt plus n dy equals 0. Next step, and this is extremely important, take the partial of the m term with respect to y and the partial of the n term with respect to t. Now, if both of these values, or sometimes they can end up being functions, if both of them are equal to each other, then we know that this is an exact differential equation. Now the next step is to say that m is equal to this term right here, okay, the partial of psi with respect to t. Now simply through integration, get rid of these differentials and end up with an answer right here. The same goes for the n term, okay? Now, so what really you need to memorize from here is this format, this condition, and that m is equal to d psi dt. Now let's proceed on to the next example. Now, number 2 there says, okay, 3x squared minus 2x, I'll just write that down right here. Number 2, 3x squared minus 2x plus 2 plus 6y squared minus x squared plus 3y prime is equal to 0. Now, first thing, is this written in this format? Well, the answer is no. It's a little bit different, and here's how we can get it into the correct format. Let's say 3x squared minus 2x plus 2 plus 6y squared minus x squared plus 3. Now, y prime, in this case, we can write it as dy with respect to x is equal to 0. Now, why is it that in the previous example I used t and here I use x? Well, x seems to be the it seems to be the independent variable in this case. Now, next thing, if we were to multiply through by a dx, in other words, with the entire expression, then we would end up getting 3x squared minus 2x plus 2 plus 2 times dx plus 6y squared minus x squared plus 3 dy. See, what happens is when you multiply the dx over here, this dx and this dx cancel out, just leaving a dy is equal to 0 times the dx. Well, 0 times anything is just 0. Now, this is actually written in this format again, where this piece is the m term, this piece is the n term. Okay. Now the next step is this condition met? If it is met, then this is an exact equation, and then we can proceed with the next steps. If this is not met, then we have to find some other method to solve these equations. Now, let's see. The partial of m with respect to y in this case ends up being, well, in this case it ends up being excuse me, it ends up being 0. The partial of n with respect to x ends up being negative 2x. Okay. Now, is this partial equal to this one? Answer is no. Therefore, this is not an exact differential equation. Same method cannot be used in this particular scenario. Okay. Now, ladies and gentlemen, that is all for this video. If you have any further questions, please let us know.